Inspired by the incredible power of clinical service dog for quick identification of emergencies, our team created LifePulse Guardian, an AI-powered mobile application for the passive identification of heart complications. Our LifePulse Guardian wearable device, in combination with our mobile app, can notify users of their need for medical attention before they themselves realize its necessity.
Ensure that the nodes on the LifePulse Guardian device are positioned as shown. Connect your LifePulse Guardian device to the app, and once connected, hit Start. Here we can see that the user's real-time ECG data displayed on this graph. It appears that the user's health is currently in good condition. Let's find out what happens when we take database ECG data from a person with a heart condition and input it into the app. The database's data is processed by our machine learning model, which determines the user's heart health. An irregular heart status may indicate underlying conditions such as arrhythmia, or even an increased risk of a heart attack in the near future. From here, the user may call a specified primary contact, or, in emergency situations, the user has direct access to appropriate authorities. LifePulse Guardian, in its accessibility and convenient design that can comfortably be worn under clothes during daily life, has the potential to revolutionize heart condition detection as well as heart emergency response. Stay connected, stay protected with LifePulse Guardian.
Hello everyone, we're Control Alt Defeat, and today we will be introducing LifePulse Guardian. But first, what is LifePulse Guardian?
Inspiration. We are inspired by service dogs who are able to help their owners in emergency situations, such as experiencing a heart attack.
Next, we will be talking about how we created our project.
So there are two main components to the project, one being the chest band, as you saw in the video. And this contains an ESP32, which is a microprocessor that has Bluetooth support, which connects to the EXG pill, which is a biopotential sensor, which can track your ECG data. As well as we have the Android app component of the data, which does the processing and the machine learning models as well.
Due to the inability to ethically induce irregular heartbeat patterns, we use a publicly available database. With this database, we train a model to output binary classification, either normal or irregular heartbeat patterns. With our model, we get a resulting accuracy of 94%.
Next, here are some reasons as to why you should choose our product.
In terms of our competitors, there's a couple. There's the Holter monitor, smartwatches, a respiratory belt, and even something called cardio, which is similar to our technology. However, they mainly focus on monitoring and diagnosis instead of emergency detection due to regulatory and liability issues. That's our main focus, the emergency part, and we aim to break that mold.
All right, so why choose us over those competitors? Well, first, our use of ECG data over PPGs, which is also common in similar technologies, is superior for ensuring the technology of our model. Secondly, our device itself is built for daily 24/7 usage and is convenient enough to wear under clothes. Real-time data processing that within our mobile app and model prediction is ideal for this sort of emergency detection due to the swift nature of the problem itself.
Here are some possible developments that we could have had.
Because the world of data is forever evolving, we would always want to keep our trained model up to date.
In terms of improved design, since this is a prototype, we'd like to be able to design the band so that it's more accessible for others to wear of all different sizes.
In regards to our app, we would like to be able to send notifications and alerts to either loved ones or people of their choice, as well as a designated contact list instead of having to manually type it all the time.
All right, thank you so much for watching our presentation. Just really quickly though, I'd like to show you all our wearable device in the flesh, if that's okay. Oh, no, Eden's giving a decline on that one. Sorry, folks. Maybe another time. At least you can see that our app is, I'm actually wearing it right now underneath my clothes. Yeah, really delivering on the promise that, yeah, it is able to be worn at all times. Anyway, just thought we'd let you know that it is indeed working. Any questions, please?
Okay, thank you for that offer, but we'll imagine it. That's good. So yeah, I do have a question. So who do you envision this for? For just an average person? Do you people with a history of heart disease? Who's your target market?
Oh, gotcha. Okay. Yeah. So yeah, we do believe that this device would be most useful for users who have the possibility of experiencing an emergency complication. The 24/7 availability of the device itself lends itself well to the ability to detect these complications at any time. So yes, definitely users with. Oh yeah, I'll pass along to Kate here.
Hi. So, I work at a seniors home, and so they still use pagers, just like the button on the wrist, and often the residents forget to wear the pager or something happens, and if something like that happened and they're not wearing the pager, if they're wearing this device, then it could send an alert to one of the managers or emergency services so that they can get help right away instead of waiting and exacerbating the problem.
Hello? Yeah. Thank you for your presentation. I have a question. You mentioned that you use publicly available data, right? Yeah. Do you mind telling where did you collect the data from and how big was that data?
So it was a ECG data collected, ECG data heartbeats of arrhythmia patients.
And how big was it? I mean, what is the number of attributes you have or in that data?
There was actually like 4 separate data sets combined into one I found in the website. Mm-hmm. I saw there was like over 40,000 rows.
Over 40,000 rows.
Yes.
Okay, so pretty much big data. And you use the binary classification model, right?
Yes.
What type of classification?
So I converted the any of the rows that said normal, I could change that value to 0, and anything that's not normal, I change it to 1.
No, I was asking in terms of machine learning, what is the algorithm for classification?
Oh, the algorithm. We use fully connected neural network.
Logistic regression.
Logistic regression. Okay, thank you.
Thanks. My question is regarding, you mentioned about the seniors home, and that's one of the bigger things around any sort of these sort of wearable devices, to keep them motivated, or the device is as good as the data. So unless and until there's conformity, people would not be using it. So people who forget to wear a watch or a pager because it's so simple, what would be the way, if you were to speak about this product, like wearing it under your clothes, it's more complex. How much do you see people actually conforming to it and continuing to use it, or after some time being like, oh no, this is more complex than just wearing a watch?
So in terms of being at a seniors home, I believe that this product wouldn't be necessarily available to all of the residents. There would be priority residents that should be wearing these sorts of devices. In terms of convincing them to wear it, or if they forget, then that would be a future development where we can integrate it with their clothes instead of a band, so they don't think about wearing it, they just put on their clothes and then they go. Or most likely the the residents that do have heart conditions, they probably have nurses that are assigned to them, so those nurses as well can be trained to remind them or make sure that those devices are attached.